Hello and welcome to 11.4 Graphing Sine and Cosine. For today, we are going to be graphing sine and cosine's parent functions and then graphing them with transformations, just like we do with quadratics and all of that. So, to begin, I want you to start with your warm-up. I want you to fill in the entire unit circle to the best of your abilities, and then I want you to find the following. So hopefully you actually did pause the video and do this. What you would get is 0, -1, 0, -1, 1, 0, 1, 0. Okay, it's not a coincidence because what we're going to be using these for is these are actually going to come up in our parent function for sine and cosine. Okay, so we got a lot of definitions today. We got oscillation, it's how much the graph of a function varies between its extreme values as it approaches positive and negative infinity. So it's just going between its maximums and minimums. Our midline is the, it's like the middle of your graph, midline. It's literally a line that cuts your graph in half. Your amplitude is how high up your graph goes. A sinusoidal function. It's a function that can be produced by translating, reflecting, or dilating. dilating the sine function. So basically, we are creating these functions when we transform it. Frequency, it's the number of cycles in a given unit of time. A periodic function is a function with y values that repeat at regular intervals. Cycle is one complete pattern of a function, and then the period is the horizontal length of one cycle. So it's a lot of words, a lot of crazy new words. So what we're going to do here is we're going to graph the parent function for sine. So on the left, I created our parent function values. Kind of get it. So we're going to start with our x values. And so what we're doing is we're creating sine of x equals y. So we're plugging these in. And if you notice, look at that. These are the values that we're going to be working with. So like sine of 0 was 0. Sine of pi halves was 1. Sine of pi, 0. Sine of 3 pi halves, -1. And sine of pi, 0. And so what happens is we repeat, which creates one period or one cycle. And so what we're going to do is we're going to graph it. So at 0, 0, we're right here. At pi halves, we're all the way up at 1. At pi, we're at 0. 3 pi halves, we're at -1. And at 2 pi, we're at 0. And so what happens is we create this curve of our graph. What's kind of cool is it kind of looks like a circle. And that's where this is coming from. These are all coming from the unit circle. And so our domain is not 0 to 2 pi, because if you think back to all of our standard positions and everything, we can keep going. So we can actually do pi halves. We can reflect, or we can keep going with our points because it follows a pattern. So we have continued our graph, and so it's going to keep going. Likewise, we can have negative values and we can go backwards on our graph. And so at -2 pi, we're ending where we started. Oopsies. Made a mistake. No, I didn't. Woo. There we go. Thinking of a different graph. There we go. So there is our graph. And so what that means is our domain is -infinity to infinity, because it's going to keep going forever and ever and ever. However, our range, remember that's the y values. So it is -1 to 1. So our range, because we hit at those points, we're going to have brackets. Now our period, that's how long it takes to create one full rotation. And so our period is 2 pi, which makes sense because the unit circle is 2 pi. And our amplitude, that's how far we are from our middle of our graph. So we are 1. Okay, so that is your parent function for sine. Okay, let's look at cosine. So again, here's our x and our y values. Cosine, so again, we're doing y equals cosine of x. That means that we're plugging these values, these x values in for x. So cosine of 0 is 1. Cosine of pi halves is 0. Cosine of pi is -1. Cosine of 3 pi halves is 0. And cosine of 2 pi is 1. Because again, we are repeating. We're ending where we're starting. So when we graph this, we're at 0, 1. Pi halves, we're at 0. Pi, we're at -1. Oopsies. Right here. 3 pi halves, we're back at 0. And 2 pi, we're at 1. And so our graph is going to look, it should curve a little bit. If you notice, I'm curving at the end. That is our cosine graph. And so it ends where it started. It's gone through one full cycle. And so our period is 2 pi and our amplitude is 1. And so we can actually, again, we can keep going. We can go back down, hit, hit, hit. This is the continuation of that cycle. And likewise, we can go backwards because again, it would go like clockwise versus counterclockwise. And so our graph would look like this. And so what that means is our domain is -infinity to infinity, but our range, again, bottom of our graph to the top of our graph is bracket -1 to 1. And so that is our cosine graph. What's really cool, I'm going to zoom out a little bit, is they kind of look the same. Right here, oopsies, there we go. If I trace here, isn't that the cosine graph? It is. So the sine and the cosine graph are the same. The only difference is where we're starting. Cosine starts at 1, sine starts at 0, and that's how we create that period. And so the domain for sine and cosine, no matter what we do, will always be -infinity to infinity. Now our range, this one will change. So for the parent function, it's -1 to 1. So this one will change. The period is the length of one cycle of the graph. And so we start to see where it repeats. That tells you where your period ends. The amplitude is half the distance between the maximum and minimum. So here is our maximum. Here is our minimum. What is halfway between -1 and 1? 0. You would add them together. And the midline, this one is more, is the middle of the function. So this is more of your halfway point. So what is halfway between -1 and 1? 0. And so this is your midline. And so y equals 0. That is your midline. That's your middle of your graph. And so what we're going to do is we are going to find the amplitude, midline, period, and we're going to tell if it's sine or cosine. So what we do to find the I would suggest starting with your midline. First step. So your midline is halfway through. So here we're at 1.5 and -1.5. So halfway between will be y equals 0. From there, your amplitude is how far from your midline you are, which is 1.5. We can also write this as a fraction because sometimes we'll see it as a fraction. So 3/2. And now your period. Now this is where I really want you to take out your highlighter. We're going to highlight. So starting from our y-axis, we're going to highlight until we complete one full cycle. And so Our period is 360 degrees, which is the same thing as 2 pi. Now, it's creating that U shape, which tells us it's going to be a cosine graph. Okay, so let's do our next one. Let's find our midline. So we're at 3 and 3. We'll just call it 3. So that means our midline is halfway through. And so our midline is going to be at y equals 0. Our amplitude is 3. Now, your amplitude will always be positive. And so what we're going to do next is we are going to start at our y value. And so this one, it's a U shape. It's our period, let's just say, is 180 degrees, which is pi. The line is not the best. And this is going to be cosine, but it's flipped down. And so that's going to be a reflection. So when we graph, this is what our cosine graph is going to look like. Okay, so that was our example 1. I want you to try to do example 2 if you can, otherwise we'll do it in class, but this kind of brings everything together. So we have our sine graph. Wow. Okay, so sine is going to look like this. I think of it as like a sideways S. Our cosine graph is that U shape. Okay, and so we can have our transformation. So your amplitude, it's always positive. It's your A value. So A stands for amplitude. Period is the length of one cycle, so it's your B value. So it's 2 pi divided by b. Now, sometimes you can have your it in degrees. You more will see it in, if anything, in radians. Your midline, it is your shifting up and down. And so your midline is your D value. And then we have this thing called a phase shift. Now, the phase shift can cause a little difficulty because it's C over B. So you're using that B term again. And it's always the opposite because, again, go back to transformations. Inside, opposite. So if it's minus, we add. Okay. So what we're going to do is we are going to graph all the, or we're going to not graph, we're going to talk about all these pieces. So our amplitude here, so here's our A sine of BX. So our amplitude is 5 because it's the, in a sense, it's the absolute value of that value. Our midline is our D value. Well, there is no value, so it's just y equals 0. And our period, which again, we're going to write it in radians. Our period is 2 pi divided by b. So 2 pi divided by 2, which is pi. And so the sketch, this is going to be our sketch, we have that reflection. And so usually our graph for sine goes like this. But because of that reflection, instead of going up, we're going to go down, and it's going to look like that because of the reflection. Okay. And so that's how you graph sine. Let's do cosine. So our amplitude, it's already positive, so it's 1/2. Our midline is 0, so we're going to have y equals 0. Again, it has to be an equation because it's a line. Our period, well, if you want to look at this for a moment, our period, we have 1/2 times x, so we're going to do 2 pi divided by 1/2, which is 2 pi divided by 1/2, gives you 2 pi, keep, change, flip, which is 4 pi. And so our sketch, notice how there is no reflection, so it's going to be our normal cosine, and so it's going to look like that. Okay. I want you to try C and D on your own, so try C and D, and we'll go over them in class. But let's move on to example 4, where we're actually going to graph together. Okay, So to graph sine, here we go. So our amplitude, that's our a value, which is 3. Our midline, there's no d value, so it's y equals 0. Our period is 2 pi divided by our b value, so it is pi. You know what's really cool? Our domain we can write as negative infinity to infinity. You will be able to write your range really quickly without graphing it, but let's do some practice problems and maybe you'll kind of see it on your own. And then I always like to draw a little shape of what it's going to look like just to kind of remind myself of where I'm going. So I'm going to take my period and I'm going to draw it all the way out here. There's pi. Well, we have 4 quadrants, so we're going to separate our period into 4. So what's half of pi? Pi halves. What's half of that? Pi over 4. What's 3 times that? 3 pi over 4. It just helps to find it really quickly. You can also you can take your period and divide it by 4. And so that is what you're going to be adding and subtracting. So like if you wanted to get negative pi fourths, if you wanted to graph more than one cycle, but all we need to do is graph one cycle. So there's our period. Now we're going to bring in that midline. So I'm going to draw it as a dashed line. It'll make sense when we start to have a different value. And then our amplitude is 3. So that means we have to go 3 away from our midline on both sides. So we have everything labeled. Sine starts at the origin. And then we're going to go up 3 because that's our amplitude. Back to 0. So every time you have to pass your midline, you have a point. That's going to work for sine and cosine. And so this creates your graph. And that is it. And so our range is bracket -3 to +3. Okay. Ooh, fancy. Let's go to the next one. Here we go. So our amplitude is 2. Our midline is y equals 0. Our period, 2 pi divided by 4, because that's our b value. So we get pi halves. And again, our domain will always be negative infinity to infinity. So from here, I'm going to graph all the way out here. I'm going to be pi halves. Now, you can do half of that, which is pi fourths, half of that, which is pi eighths, and then 3 times that, which is 3 pi eighths. So that's personally what I like to do, but you can also, again, take your period and divide it by 4. So that's where we get that keep, change, flip to get pi over 8. I'm going to bring in my midline, which is here. And then I'm going to bring in my amplitude, so that means I have to go 2 away. And then cosine is where it starts at my amplitude, going through my midline, so I have a point, going down, midline, up, and so my graph looks like this. So it is -2 to 2. Okay. We're going to skip example 6 and 7 for right now because I want to do one phase shift. This is our last problem we'll do together. So our amplitude is still 1. Our midline, because we have a d value, is 2. Our period, remember it's 2 pi divided by b. Well, it's just 1, so our period is 2 pi. And our phase shift is c over b. Well, c is pi, and b is 1. So we have pi, but we do the opposite. And so we're going to go pi to the right. Okay. And again, our domain, always negative infinity to infinity. It's like a free point. So I always start with my midline. It's going to be at 2. Okay. From there, I graph my phase shift. So we are pi to the right. And I'm going to draw a dashed line. What this does is it creates your new x and y axis. It helps me, okay? from here, I'm going to take that phase shift and I'm going to add my period. So pi plus 2 pi gives me 3 pi. That's where I'm going to end. And so taking my period and dividing it by 4 gives me pi halves. So I'm adding pi halves each time. So I would get 3 pi halves. No, yeah, yes. 2 pi. So that's 1 or 3, 4, 5 pi halves, and then 6. Okay? That's why this method might be better to set up your numbers, but it really depends on how you feel. And then from here, I'm going to bring in that amplitude. So I'm going to go up 1, down 1. And so now that I have everything, I have that sine, which is that sideways S. So I'm going to, again, start at the origin. It's my new origin. Go up 1, back down to my midline, down 1, back to my midline. And so that creates your sine function. It's only one cycle. If you wanted to, you could technically keep going and be bougie if you want, but I only need one cycle, and that's this. And so our range is bracket 1 to 3 with a bracket. Maybe you figured out how you can find your range really quickly, but that is graphing sine and cosine using transformations and phase shifts. We will do the rest in class together.